The topics of physics has not only started in the lab settings, but can also be found on a daily basis. Hence, there is no doubt that physics can be applied to everything around us. For example, the objects that are easily found in the kitchen, ice cube, even though they may be very simple, they are actually demonstrate a physics concepts. The ice cubes are being made to collide, enacting kinetic energy, and this energy is then made to cause the ice cube to move apart. Here, the ice cubes do not lose their kinetic energy when they become stationary again, but their energy is rather transferred to each other and their surroundings.
But why does this happen, T?
Well, the concept being applied here including elastic collision, conservation of momentum, and frictional forces can also be found in the game of billiards. This will now be explained a greater understanding of the physics phenomenon.
To begin, we will start with a pool table, acoustic, and billiard balls.
Kinetic energy is gained during this action from the initial storage of potential energy, and this kinetic energy develops until it is transferred from the acoustic to the initial stationary ball 1. As ball 1 gains its kinetic energy, it slides down and collides with the stationary ball 2 from ball 1. At this point, the rate is transferred and pushed away to travel in a different direction, but one still keeps sliding. It still maintains some kinetic energy.
What happens then? Each ball will have a smaller individual velocity than the total resultant velocity after the collision occurs. This is shown in the picture where v1 represents the velocity of ball 1 and v2 represents the velocity of ball 2. Even so, there is still the same net kinetic energy. This is the basic idea behind elastic collision. The conservation of kinetic energy is defined as follows. There is no loss of kinetic energy when the collision of two billiard balls, 1 and 2, occurs.
Elastic collision kinetic energy is conserved. Initial kinetic energy 1 is equal to the sum of final kinetic energy from ball 1 plus the final kinetic energy from ball 2. Is it also being expressed as 1 half m1v1 naught square equal to the sum of 1 half m1v1 square and 1 half m2v2 square. In addition, linear momentum may also play a main role in the collision between two billiard balls 1 and balls 2. The conservation of linear momentum is highlighted so that the total momentum of the system will remain constant when there are no outside forces exerted on the system. So we have determined that the conservation of linear momentum is P initial P is equal to final P, which is m1v1 naught is equal to m1v1 plus m2v2. And because they have similar mass between the two ball 1 and ball 2, we could say that m1 is equal to m2. Therefore, v1 naught is equal to the sum of v1 plus v2.
Furthermore, friction greatly impacts the system, making it one of the main physics concepts affecting elastic collision in the two billiard balls. Friction forces occur in both the surface of the pool table and especially at the collision of balls 1 and 2. When on a pool table, the balls will move slower than when on a smoother surface, such as a ping pong table, as smoother surfaces have fewer grooves and, subsequently, generate less friction that would stop the movement of the objects. The frictional force occurring at the collision reduced the initial velocity of ball 1, known as v1 naught in the diagram, and not only lowered the final velocity of ball 1, v1 in the diagram, but also transformed potential energy to kinetic energy in ball 2, thus increasing the velocity of ball 2, v2 in the diagram. The frictional forces are determined to have opposite directions, with the normal force occurring in balls 1 and 2, giving reason for why friction is an inhibitor to movement. When there is less friction acting on the system, greater energy will be converted to kinetic energy in an effort to augment the individual velocities of the balls and bring them closer to an ideal elastic collision.
In conclusion, the physics concepts such as elastic collision with conservation of kinetic and potential energy, conservation of linear momentum, and friction are thoroughly described under the physics of billiards. Thank you for watching.